At a grain mill somewhere in North America, a covered hopper rolls away from the unloading track. Its cargo is gone, so from the roadside the car looks useless. It may now travel hundreds of miles without carrying a single new product. Yet this apparently empty journey is part of an enormous sorting system that keeps factories, farms, ports and warehouses supplied. The car still has an owner. It still has a destination. Another company may already be waiting for it, and several railroads may have to cooperate to get it there. So what actually happens after a freight car is unloaded? The answer begins with a small action at the customer's siding and ends with a new load that could be half a continent away. Our hopper cannot simply leave when the last grain falls through its bottom gates. Workers first confirm that unloading is complete, close and secure the gates, and check the car's condition. The exact procedure depends on the railroad, the customer, and the type of equipment. A boxcar needs its doors secured. A covered hopper needs its hatches and outlets checked. A tank car may require an entirely different set of steps. Then the customer releases the car to the serving railroad. Today that often happens through an online system or an electronic message. The release tells the railroad that the car is ready to be pulled from the industrial track and identifies whether it is loaded or empty. That status sounds simple, but even the word empty has limits. A tank car that has been unloaded as far as practical may still contain hazardous residue and vapor. Until it is cleaned and purged, it can remain subject to hazardous material rules, markings, shipping documents, and inspections. Once released, the car becomes a moving assignment. The letters and numbers painted on its side are its permanent identity. The letters are called a reporting mark, while the number distinguishes that car from every other car carrying the same mark. Together they act like a license plate that can be read by people, cameras, scanners, and railroad computer systems. Behind that visible identity is a much larger digital record. Rail Inc.'s AMLR system contains critical data for more than 2 million pieces of North American rail, highway, and steamship equipment. For a freight car, the record can include dimensions, capacity, lightweight, load limit, inspection information, and special equipment. Railroads use those details to decide whether a car can be accepted, where it can travel, what it can carry, and how it fits into a train. This matters because the railroad pulling the car may not own it. Freight cars can belong to railroads, leasing companies, or private businesses. A car can also move across several railroad networks during one trip. At each interchange, the new carrier needs a reliable identity and an accurate description of the equipment it is accepting. The steel car may be old-fashioned, but its journey depends on a shared information network. Now comes the first physical move. A local switching crew arrives at the industry, couples onto the released cars, connects the airline, and pulls them toward a nearby yard. The crew may serve several customers on the same run, gathering a mixed collection of boxcars, hoppers, gondolas, and tank cars. Some are loaded, others have just been emptied. They are not yet a long-distance train. They are pieces waiting to be sorted. Inside the yard, the destination matters more than the cargo status. Cars headed toward the same next terminal or connecting railroad are grouped into blocks. In some yards, a locomotive pushes cars over a low hill called a hump. Each car is uncoupled, rolls down by gravity, and is slowed by trackside retarders before entering the correct classification track. Other yards use locomotives to flat switch cars from track to track. Either way, the goal is to turn a random arrival into an organized departure. An empty hopper can therefore sit beside a loaded boxcar because both need the same route for the next part of the trip. What looks like a strange mixture from a highway bridge is actually a set of destination groups. At the next major yard, those groups may be separated and combined again. The car is not following one train from beginning to end. It is passing through a network of trains. Why not leave every empty car at the first yard until a nearby customer needs it? Because freight equipment is specialized. A covered hopper designed for dry bulk material cannot replace an automobile rack, a refrigerated boxcar, or a tank car. Even cars that look similar may have different capacities, linings, outlet arrangements, or loading restrictions. The next customer needs the right car, not merely an empty one. Geography creates an even bigger problem. Freight flows are rarely balanced. A region that receives finished vehicles may not manufacture enough vehicles to refill every returning automobile rack. A power plant receiving unit trains of one commodity does not produce a return cargo suited to the same cars. A food processing plant may need clean covered hoppers from a particular pool. The equipment must go where compatible demand exists, and that often means moving empty first. Some private cars are automatically sent back toward the origin of their previous loaded trip unless different instructions are provided. Others are directed to a new loading point, a storage track, a cleaning facility, or a repair shop. Railroads and car owners continually try to shorten these empty movements. Union Pacific's car order policies explicitly aim to reduce unnecessary empty miles, while BNSF has worked with customers on routing programs that reduce the miles and yard handlings of returning empty hoppers. The crucial word is unnecessary. Empty movement itself cannot be eliminated from a one-way flow. If a hopper carries grain from a producing region to a distant consumer, the car has to return toward another source before it can earn a new loaded trip. Better planning can choose a shorter return path, match the car with a closer shipper, or keep too many cars from entering a congested area. It cannot place tomorrow's cargo inside today's destination by wishful thinking. Every extra handling also has consequences. Switching requires track space, locomotives, crews, and time. Changing a train's consist can trigger brake inspections and tests before the train continues. Federal rules still require a Class 3 brake inspection when freight cars are added to a train. Removing one car just because it is empty can therefore create more work than carrying it to the terminal where it was already meant to be sorted. But an empty car is not handled exactly like a loaded one in every respect. Its weight is far lower, and the brakes on freight equipment must account for the difference between empty and loaded conditions. Train makeup, placement rules, route limits, and the behavior of long strings of cars all depend on the equipment involved. This is why railroad operating systems need the car's actual specifications rather than a vague label such as hopper or tank car. There is also a quiet accounting system following this deal. When a railroad uses a car owned by someone else, car hire can apply. Rail Inc. describes car hire as rental paid by railroads to equipment owners, with records based on time, mileage, and interchange events. That creates another reason to know exactly when one carrier accepted the car and when it handed the car to the next. A missed electronic event can assign responsibility to the wrong company, even though the physical car kept moving normally. At the interchange point, one railroad places the car where another can receive it. Both sides report the event, and the shared records establish when possession changed. Critical equipment information also has to be current, because the receiving carrier needs to know the car's dimensions, limits, inspection dates, and modifications. Rail Inc. says hundreds of thousands of freight cars are interchanged on a typical day. The network works because each participant recognizes the same identity. Our hopper may pass through several yards before reaching its new loading region. Along the way, trackside detectors can examine wheels, bearings, and other equipment as trains pass. If a defect is found, the car can be removed from service and routed for attention. Empty does not mean exempt from mechanical standards. It still has to roll safely, couple correctly, and operate its brakes. Eventually, a local train delivers the hopper to another customer. The car is placed on a siding, inspected for suitability, and prepared for loading. Only then does the empty journey end. Grain, feed, fertilizer, plastic pellets, or another compatible dry bulk product may flow through its roof hatches, depending on the car's design and service restrictions. New shipping instructions turn it into a loaded shipment, and the entire process begins again in the opposite direction. Seen from the road, the car looked like dead weight. Seen from the network, it was inventory being repositioned through a chain of customers, yards, carriers, databases, inspections, and handoffs. Its lack of cargo was only one temporary condition among many. That is the hidden return journey of a freight car. The loaded trip delivers today's product. The empty trip places the equipment where tomorrow's trip can begin. Rail freight depends on both, even though only one of them is obvious.